pattern, and the pattern is very similar to the shape of the final item. So you can hand that around. We're going to talk about some of the features of that pattern and why it's made to that particular shape. And as we go through, Bruce will talk about sand, what's important about sand, the actual constitution of it, and show you how we've got the runners, risers and feeders, etc. put in. And it won't be an ideal casting when we've finished. Okay, so have a good look at that pattern. Some of the features of it, you'll see there's a goldy or yellowy colour bit up the centre of it. That doesn't occur in the final item, and Bruce is showing you there. It's a bit of sand moulded with, what's the binder again, Bruce? CO2 and...
Sodium silicate.
Sodium silicate. And it's what we call the core. Yeah, so anywhere you want to make a hollow shape, we have a core. So the water jacket in your automotive engine, that is made by some sand that's specially bonded together, put in there, and it will break down later and we'll remove it. We generally remove it through some holes, and those holes are what are known as Welsh plugs. So that's why the holes are there in the side of your engine block. It holds the cores in, and it also lets us remove the core material later.
Okay, you've just had a look at some shrinkage patterns that can occur. Where do you think would be the last piece of this to solidify? These thin bits, this big round bit, or the big round bit and the intersection of the square bit here?
The intersection.
This bit. Okay, so that's probably going to be the last bit to solidify, so that's where we should have any feeders coming in, so that we've got molten metal continually available to there. I'm going to do exactly the opposite today and try and exaggerate that. So I'm actually going to put my feeders in from the end here and try and get as much shrinkage as possible to make this a terrible casting. Okay, so I split the box and split the pattern. I'm going to make half in one part of the box and the other half in the other part of the box. Okay, I'm setting it up so that I can feed the metal in from this side, in through the thin areas, and hopefully get a terrible casting. The sand's been prepared down here. I'm stolen my shot. And it's reused sand, so we find little bits of moulding sand, bits of metal in it, dried pieces of sand. Will this make a good reproduction of the pattern if I use this sand? No. So I have to do something with it. Now I could either use a thin facing of really high quality sand, or I can just sieve this and get the worst of the rubbish out. And that's the way I'm going to go today. Nice and cheap. Just get some of the sand and remove things that can get rubber. So these old bits of core. This is not too bad. Okay, so my sieved sand is now going to give me a good reproduction of the pattern. Is this like the sand you find at the beach?
Nope.
Oh, it is mostly. What's different about it?
Black.
It's black. So there's obviously something been added to it. What do you think's been added? Carbon, that's right. Just ground up coal. Okay, what's the carbon for? The opposite, actually. It'll burn out and make little gaps. Okay, now, with the aluminium today, it's not going to be hot enough for that to happen, but if we were using cast iron or brass, it would be hot enough to burn some of the carbon out and produce gaps so that steam and gases can get out. The other thing it does is the oils that are in the natural coal will form a nice highly viscous layer, and it will improve the surface finish. Okay, can you do this with beach sand?
No.
So there's something else in here. What do you think's in there?
Phosphate glue to hold the sand together.
Yeah, what is it?
A little bit of glue.
Glue, yeah, okay. What's a natural glue? Remembering this process goes back 10,000, maybe 100,000 years. So what's a natural glue?
Sugar, glucose.
Something even simpler. Okay, this would have been done by a riverbank, thousands of years ago. Clay, that's all it is. So that's all the components of our sand. The sand itself, a little bit of clay and a little bit of coal dust. Okay, but very carefully controlled little bits. Got too much moisture, when we pour the metal in, it will just explode with all the steam. Too little moisture, it won't hold together. Too much clay, the same thing. Okay, so it's very carefully controlled, little bits of these things in there. Also, the sand itself is not just the sand you pick up at the beach. It has to be river type sand. In fact, the sand we've got here is from the back end of sand dunes. So it's a sand that was in the water and it's been blown over the sand dunes and tumbled over itself. What happens when the sand grains tumble and tumble and tumble? They weather, reduce in size. What shape do they end up? Round.
Smooth.
So these are round, smooth grains. So they will roll together and they will roll into those corners. If we had bricky sand, the sharp stuff that you get at the waterline, it won't give a good mould. So, although the technology is tens of thousands of years old, there's a lot of smart little things in there in something as simple as moulding sand. Okay, let's do something with it now. I've got my face sand in, so the rest of this, that can go in behind it. It's not going to affect the reproduction of the shape. Now I have to make all this into one big lump. So I've got a nice big hitter, and I can dot it into the corners. Can I do that over the pattern? Remembering it's
Probably not, so crack it.
crack it, bend it, and that. So I have to be careful with it. I have to know where to hit it hard and where to hit it soft. Okay, and I also have to remember the shape I've got it in, so that I can force the sand into those areas I want it to go into. I don't want to form one layer and then put another layer of sand on it and have the two separate later on. So I've left that randomly thumped down. Okay, now that I've got quite a bit of sand there, I can get in pretty evenly, make it flow into all the corners. Finally, give it an even ramming all over. Cast iron. I need this to sit flat, so I'm just going to scrape a flat layer out. If I was doing a great big casting, would it be feasible to do it in a box like this? Great big casting. Would I be able to do that with it? No. So in a big casting, I normally do them in place, work the way up from the bottom. Just dig a big pit in the sand.
Big hole in the ground, they'll generally have brick walls around it, and there'll be a team of moulders working in it, and there'll be all bits and pieces moulded up to actually hold in place. The mould will often be held together by things called chaplets, which will hold cores and things in place, and then when they put it all back together, it'll take months to put together. They'll put big lumps of steel over the top to hold it all down. When they actually pour the metal, could take up to 3 hours or so to pour the metal, and then it could be in the ground for a month before they actually pull it out of the ground. Big castings.
Okay, small ones are fine like this. I can turn them over. Today's foundries don't work horizontally when they're doing multiple castings. See on the board there, we've got multiple patterns. We could do all those in one go, the same as I'm doing one at a time here. Modern foundries tend to do that, lots of castings in one go, but they do them vertically. So the joint between the two will be vertical, and they just stack them all together. So each mould box has two half impressions in it. And when you put two together, you get the full mould between each one, and they just keep churning them out. Hundreds and hundreds and hundreds. They use compressed air to round the sand. Okay, that's set up. It's not a real good match. It goes that way. Too moist. A little bit back there. Okay, I've got one layer of sand and I've rammed it. I'm now going to put another layer of sand on top. And when I ram it, what's going to happen?
Push the sand out the road.
It's all going to join together. How can I stop that? Well, what forms the bond?
Like,
Clay and a little bit of moisture. How can I stop that bond forming? Make it dry. Yep. And there's a real simple way to do that. Just pass that bucket over the scrubber. We're going to use a little bit of talcum powder. It'll take the moisture out of the clay. Okay. So, now when I put sand in, it won't stick to the existing sand. So, just going to repeat everything I did on the other side, but I'm going to make two differences with this side. One is, I've got to be able to get metal in, and the other is I've got to encourage the steam and gas to come out through the top. Okay, so that's just exactly the same as I did with the other side. I've got the sand in there to start building up the layers. Okay, this time, when I cut the part into the corners, it's going to also affect the bottom layer. They're not going to join together, but they're going to be pushed around. Will that matter? So why won't it matter that the bottom layer is now being distorted? The top layer will exactly match it. It's still going to be a tight seal. It's easy to cut. Okay, do I have to make this side flat? Well, I don't have to pour it, but actually to get the mould out, I'm going to have to turn the box upside down, so I really do have to make it flat. Okay, now do you think we're going to be good enough to be able to hit that little tiny hole with a great big pot of molten metal? So we'll make the target a little bigger. Just cut a big hole around it. We ought to be able to hit that. Remember I said I was going to let the gases get out easier? Okay, I know the pattern is that tall, so if I restrict myself to that height, I won't hit it. Hopefully I can put an in, because I know the pattern's here. Okay, here comes the clever bit. We've got to get the metal to go from that hole I put in over to the pattern. So we're going to need to do a little bit more. Notice on that one with the multiple patterns, it's already built into it.
So I notice it's taken a fair bit of time here for Bruce to do this, and it's fairly labour intensive. So the obvious advantage of the more modern systems is that they can do a whole lot of castings in virtually one go. So they just make up a melt, and they've got a line of these castings, and they just pour and pour and pour.
Let's get it out. Why do we need a taper on the casting?
On the pattern.
On the pattern?
Pattern?
So that it won't drag the sand out. Now, it's still may, because I'm pulling that pattern apart rather than hitting directly into it. Wreck the corner. Okay, is that a big problem? Oh, that's what these things are for. So I've lifted this corner up here. Okay, what we'll do.
Effect a repair.
Yeah, see how clever I am. Pull yourself back down. Also, to help the gases get out, I put holes in the top side. In the bottom, I really can't do that because there's no way it's going to get out through the bottom, but it can get to the edges. So if I just put a few little scrape lines in, any gases that get through that first layer of sand will find an easy path. At the edges here. Okay, I think they had this technology around 10,000 years ago? Yeah, probably. Leather and wood. Okay.
So one more thing to do before we put the cope and drag box back together and make the mould. Put the core in to produce the whole up.
If the sand collapsed now, we don't start making.
If I've got the right clay and moisture in there now.
What do you do when you once you've put the mould in? See how here you can. What do you just take the excess metal that's in this indentation? You just take that off.
Yeah, we'll just cut it off at the end of it.
And it's
cleaned up.
recycled.
Yeah, it's called fettling.
Uh,
Is to take off all the extra bits and make it the shape it should have been. Still some loose bits in there.